Hello, and thanks for joining us today. For this presentation, we're going to have Jake Willsea talking about does more frequent digester effluent application influence carbon intensity scoring and uh, the economics of effluent storage. So I think it's a pretty interesting topic, something that we haven't touched as much on yet, since it's related to digester effluent utilization. And since Jake was traveling today, he pre-recorded a presentation, so we're going to try something a little different, but he is here in attendance to answer some questions for us at the end. So if you have any questions during the presentation, feel free to type them in the chat, or you can save them to the end and we'll try and address them then. So if I do this right. Okay, so here's Jake to start presenting for us.
Hi, everybody. My name is Jake Willsea, and I'm currently a master's student at Iowa State University studying agricultural engineering. Today, I'll be talking to you about digester effluent management and specifically how application frequency of that digestate can affect your methane emissions coming from digestate storage, your nitrogen use efficiency, and just the economics of the system as a whole. So a little bit of an outline of what I'll be talking about today. First, I'll get into the basics of manure management in Iowa, the background of the system. And then specifically, we'll talk about swine manure digesters and some of the challenges that we face when we're trying to implement those. We'll have a cost assessment for different digestate storage sizes, and we'll discuss how the frequency of your digestate application affects your storage cost. And then we'll get into some strategies for methane mitigation coming from your storages. And then we'll look into a new tool that we could use for digester effluent management, which is the 360 Rain from 360 Yield Center. And we'll talk about some of the benefits there in both digestate management, just to get it out in the field, but also as a fertilizer. So a little bit of background on manure management in Iowa, specifically in swine farms. There's about 50 million pigs raised in Iowa every year. We're the largest pig producer in the country, and the average swine farm has about 4,800 head per farm. And the vast majority of those are in deep pit barns. So just like you can see here in the figure, there's a below barn storage of manure with a slatted floor, and so the manure drops straight into the pit. And that's really what we see for most Iowa swine farms. That's about 80% of Iowa manure is stored in there. Most of the manure is fall applied, and right now that's preferable to a lot of farmers because there's dry field conditions in the fall, and after harvest, the schedules for field operations are not quite as busy as you might see in other seasons. In terms of digesters, in the U.S., there are 83 complete mixed dairy digesters, and there's only 11 swine digesters. And in a little bit, I'll get into some of the background on why we see less adoption with some of the swine systems, and they're picking up on the digester trend. So in a typical dairy system, when we're installing a digester, before you install the digester, you already have the barn and you have the manure storage. And so because of this, after you install the digester, all you really need to have is that digester itself in a very simplified form. Of course, a lot of you probably know that there are all kinds of other pieces of the system, but on a large scale, this is all that you install is the digester itself. Then you can store your digestate in what was previously your manure storage. Now, in a typical swine scenario, you have the deep pit storage, which is below the barn. And so the barn and the storage are all built in together. And this kind of comes as a challenge when you're trying to install the digester, because you have a full year of storage already built into the barn, and you can't really get rid of that, and you can't really use it for anything after you install a digester. So in the case where we would install a digester on a swine farm with a deep pit, you have to really treat that more like a shallow pit storage. And this can be a challenge as well. You have to store it up just a couple weeks and then pump it off into the digester. But now you have to have this secondary storage structure to store your digestate as well. So because of this, it can come as a pretty large expense to a lot of these swine farms, and that's part of the reason that we don't see a lot of these digesters here in Iowa with all of our pigs. So this new storage structure comes at a pretty significant expense for a lot of these swine farms. Even at our smallest size, so about 1,200 head, you need about 500,000 gallons of storage for a full year of storage. Now, this will cost you about $150,000 just for a small farm like that. Now, they may not be installing a digester at this scale, but just for the sake of the analysis, we looked at a farm this size. Now, on a typical 4,800 head farm here in Iowa, you need about 2 million gallons of storage. And this will cost you about $350,000, which, again, just for storage after the digester, this is pretty expensive, especially considering that you're already buying the digester and all of the equipment that goes with that. Now, we do see some economies of scale. So as you get larger and larger sizes, your dollars per gallon is going to decrease. But really, a lot of our digesters are going to be definitely over 1 million gallons of storage for a full year of storage. And because of that, we're not going to see very significant changes as the size increases beyond the point that we're already at. Now, because of this new expense of the new storage, we want to look at different ways that we can minimize the cost of this digestate storage. And really, there are two options that we could consider. Now, the first option could be something like an effluent treatment and discharge, which would be similar to what we could see at like a municipal wastewater treatment process. Now, this would have some filtration processes and then different biological processes that go along to clean out this manure or the digestate and separate the water from it, which can be discharged right back into a stream as clean water. Now, this is something that I won't be talking about today. This is something that may come up, hopefully, in this webinar in a following topic. But today, I'm going to be talking about how we can use more frequent applications to minimize the cost of the storage. Now, some of the advantages of reducing the size, of making more frequent applications is that you don't need to have quite as large of a storage. If you're going to be applying twice a year, you only need half the storage that you would have otherwise. Beyond that, we also see some effects of methane emissions mitigation. And so even after you digest this manure, there is still some carbon left in it. So we do see some methane emissions coming from digestate storages. One other benefit of this would be that the fertilizer value of this digestate can be improved if we're going to be applying this digestate more frequently. So first, we're going to discuss how this reduces the required storage volume. So if we just look at applying twice a year, so every 6 months, we can see that the required storage size is cut in half, as you may expect. And because of the economies of scale, you don't quite see a 50% reduction in cost, but you still do see about 34% savings on this system, which if you're going down from $230,000 to $116,000, that can be a big deal on your farm. We also looked at applying every 4 months and every 3 months, so making 4 total applications across the year. And this is really our upper limit of number of applications that we can do evenly spread out across the year, because we want to avoid applying on snow. And so if we can apply maybe early to mid-December, really the next time that you can do that is probably mid-March. So that's really our upper limit of how many applications we can make. And if we look at that, your storage size is about 500,000 gallons, and you have about 56% savings on that system. So this really, if we can cut it down to about 4 annual applications, that can have some significant effects on the affordability of this new storage volume. Now, I'll discuss a little bit how these more frequent applications can mitigate some of the methane emissions coming from your storage. Methane emissions coming from storage is really a factor of, one, the storage duration, or I guess in other words, the volume of manure or digestate being stored at any given time. If you're storing more digestate, you have more carbon available to be broken down, and you're going to be emitting more methane. Similarly, the digestate temperature in your storage is definitely a big factor impacting your methane emissions. We look at it as it's a biological process, and so as you see in a lot of biological processes, an increase in temperature increases the biological activity. And so we usually say that for every increase of 20 Fahrenheit or about 10 Celsius in temperature, you're going to be doubling your methane production. And so if you can apply your manure strategically at different times to avoid a large amount of volume or a large amount of manure or digestate being stored while the temperature is going to be high, then if we can limit that, we can limit our methane production. So we looked to model this, and we looked at this at 3 or 4 different application scenarios. So our baseline scenario, which is our fall application, a spring application, which we said occurs on April 15th, side dress application occurs June 1st, and then we also analyzed a scenario where we applied every 3 months, so 4 annual applications. Now, as you can see, the fall application, it closely mimics the temperature trend. And so our temperature here we assumed to be the 10-day moving average ambient temperature. Now, it closely follows, we expect, the ambient temperature, but with some dampened effect because of the volume actually being stored there. But we see that when we apply in fall, we're applying right before our temperatures decrease. And so our emissions over winter are already minimal. We also see that our volume increases during our peak temperature months. So June, July, August, September, we have the highest amount of manure being stored because we're applying in November. So with that, we see an increase in volume, an increase in temperature. So we see this big spike in methane emissions. Now, if we just switched our application date to April, now we see that we're emptying our storage right before our peak summer months. So our peak methane emitting months. If we can cut our volume down while our temperatures are high, we're still limiting our methane emissions in a way. A similar effect is seen in the side dress application. We're cutting down on our volume being stored. So even when our manure or our digestate is very hot, we're not going to be producing as much methane because there's not as much carbon to be broken down. Now we see a similar effect in changing frequency of applications. Now instead of adjusting how the temperature of our manure, now we're adjusting the volume of it. And if we can just minimize the year-round storage of our digestate, we're going to be reducing emissions year-round. So those are both feasible strategies for cutting down on emissions. Now, looking at this from a different perspective, we see that a fall application, or our baseline application, emits about 0.1 metric tons, about a tenth of a metric ton of carbon dioxide equivalents per pig space. Now, compared to a manure storage, it's about 4 times more because we are assuming that there's about 3/4 of our bottled solids being broken down in this digester. Now, if we shift this to a spring application, we see about a 50% reduction in carbon dioxide equivalents, so in methane emissions coming from your storage. Same effect is seen for side dress, but then we get into some split applications. So we look at a fall-spring split, a fall side dress split, a spring side dress split, and then a 3-way split between fall, spring, and side dress. And then finally, we look at the one that we analyzed in the previous scenario, the previous slide, every 3 months. And you can see that the more frequently you apply that manure or the digestate, there's a more significant reduction in methane emissions coming from your storage compared to our baseline fall application. Now, this CO2 equivalence reduction comes as an opportunity for a lot of these digester projects because we have opportunities for LCFS credits, the low carbon fuel standard credits. So when you're making a low carbon fuel like we do in a digester, any emissions abated comes as a credit to you. Now, we use the current LCFS price of about $60 per metric ton of CO2e abated. This is kind of a low value historically, but we wanted to keep it pretty recent and relevant. Now, looking at this system, we see that our baseline emissions for fall, spring, and side dress and applying every 3 months are all listed there. And so the abatement is really just the difference between that certain scenario and our baseline fall scenario. So if we have a $60 credit for a metric ton of CO2 abated, we see income in our systems of about $16,000 in the spring and side dress scenarios. And then if you apply them at the most frequently as we tested here, we see about $26,000 of extra income coming to this farm. Now, this is a pretty significant value here. And you might be thinking, an extra $26,000 would be great, but we're busy. We want to, we have these time constraints of our farm that we can't be going out and applying this digestate all the time. Or we don't want to be spending extra money for custom manure application 4 times a year because a lot of these high application costs can be a limiting factor. So how can we find the time to do all this? Or how can we afford to do all this? This is where the 360 rain comes in. This is an autonomous high clearance irrigation system, and we could apply our digestate using this machine. We can apply this throughout the entire year. That's one of the beauties of this piece of equipment. It has a 60 to 80 foot wide boom, depending on the version that you buy, with a 10 foot clearance under the boom. So when we drive this out in our fields, we are able to apply this digestate to the corn during the entire growing season. We can spoon feed the nutrients to the crop in a way that we can put it on right when the crop needs it. Now, we have about 200 to 250 gallons per minute flow rate, and they can cover about 37 to 50 acres a day, again, depending on the version that you buy. There's also root level application here. So this is unique from what you would see in a center pivot system. You're able to apply these nutrients at the roots, and you don't have it all over the corn's foliage, which can be an issue sometimes. So we have Y drops that are dropping down at every 2 row interval so that it can cover each of the rows of corn. This has been approved for water, nutrients, and manure application. And I currently have some trials going on using this for manure application up in north central Iowa. Now, beyond the ability to effectively side dress different shaped fields, so you can, if there's irregularly shaped fields, this can cover it. Being able to side dress, besides being able to side dress the corn, it also makes split applications possible throughout the year. So there doesn't need to be corn in the field to be applying this digestate. You could be applying at various different points throughout the year. And again, you're cutting down on the custom manure application requirements because now this is an autonomous system. It drives itself. It follows the planters, the GPS of the planter, and it's a really great tool that I think will be a great opportunity for digestate management moving forward. Now, from an economic perspective, this machine does come with a pretty significant upfront cost, but again, so does this anaerobic digestion system in general. Now we see in our traditional digester scenario, our storage is going to cost us about $350,000 for our 4,800 head farm. And this is for a full year of storage. Now, if we switch to being 4 annual applications, so applying every 3 months, you only need a quarter of the storage size. And so in doing that, you're cutting down the cost of your storage to about $150,000. Now, the rain machine does cost about $275,000, and we assume that it comes with a lifespan of about 10 years. Now, even though you do have that initial upfront cost, when we do have that system, because of our reduced storage size, we are getting the LCFS credits across those 10 years. And those will come out to about $265,000 totaled up over the 10 years. And so if you look at it from this perspective, you see that after 10 years of operation, this rain machine pretty much pays for itself just on the LCFS credits alone. And then you're really doing a one-to-one comparison between the previous storage and the new storage. And so you're saving almost $200,000 across those 10 years. Now, finally, I wanted to discuss the fertilizer value of this digestate as well, and how application frequency can have some beneficial effects on our fertilizer value. So when we're talking fertilizer, especially in the Corn Belt here in Iowa, we're talking about nitrogen. And really what we're concerned here with nitrogen application timing is the nitrogen loss pathways. And the longer this nitrogen is in the field, the more at risk of loss it is through any or all of these pathways. Now, when we want to apply nitrogen, we want it to be going through this pathway, plant uptake. But a lot of the time, that's not always what happens. We have denitrification that happens when you have this nitrogen sitting in warm soil for long periods of time. It will be denitrified into dinitrogen gas and lost to the atmosphere. Similarly, with volatilization, when you apply, typically you'll see that ammonium that's in ion form in the liquid manure will then turn into gaseous ammonia and again be lost to the atmosphere. And we'll also see leaching. So when you have this ammonium in the soil, it can be nitrified, turning into nitrate, which is then very prone to loss through water drainage in the soil. Now, when we have a fall application, this nitrogen is sitting in the soil over the fall, the winter, the spring, and then it's finally taken up by the crop, hopefully in the summer. If we can cut that down to being only a few months, so maybe you apply your nitrogen mid-spring, and then you have a few months maybe that it's sitting in the soil and then taken up by the crop, then you're cutting down on really the amount of weather that it experiences. So if it rains, it experiences less rain, it experiences less of the warm soil that you could see with an early fall application, and a lot of those associated losses. So really, we want to try to limit the amount of time that our nitrogen is sitting in the field. Now, we did a literature review of various studies that were looking at nitrogen application timing. And so they applied different rates of nitrogen in different seasons. And here's a quick summary of our results. Now, you can see here that side dress applications seem to show the strongest response to nitrogen application. So the steeper initial line is really an indication that there's a stronger response. So at a higher rate, so maybe we want to say around 150 pounds of nitrogen, if you apply it in the fall, you might be getting about 90% of your maximum yield. So in a typical 200 bushel per acre system, you might be getting 180 bushels. If you just shift that application to a spring or a side dress application, now you're looking at about 95% of your maximum yield, and you're putting on another 10 bushels of corn just only by shifting your application timing. So 10 bushels in this system could come out to be $40 to $50 per acre, which is a pretty significant value. Now, similarly, you may be familiar with MRTN, the maximum return to nitrogen. And this is basically looking at when does an extra pound of nitrogen not pay for itself with the yield that it's producing. And so you can see this line starts to level off that around 200 pounds of nitrogen per acre. If you put on more nitrogen, the crop response is not going to be quite as strong. And so it might not pay for itself to put on excess nitrogen there. So we looked at this here, and you can see that fall applications tend to have the highest economic optimum nitrogen rate while still not even bringing in the same net income as you would in your other systems. On the other hand, side dress applications have the lowest economic optimum rate, and so you don't need to apply as much nitrogen, and still you're going to be bringing in more net income compared to your other scenarios. Now, from an environmental perspective, this is what we want to see. We don't want to have to be applying excess amounts of nitrogen because that nitrogen that's lost is going into our waterways and causing eutrophication. So if we can limit our nitrogen rates, it's saving you money as a producer, and it's reducing the amount that's being lost to the atmosphere or to the waterways while still bringing in more income than you would otherwise. Now, I touched on this before, but coming back to it, the reduced labor costs is another benefit of this 360 rain system. It's an autonomous irrigation system and an autonomous digestate application system. And so because of that, you don't have the labor expenses of your custom application of your digestate. Now, really, you're effectively only paying for, besides the machine, the operating costs of this machine, which is your pumping costs and the cost of fuel for this to be driving around the field, which is pretty minimal. The operating costs we calculated are about 5% of what you would see in a typical custom manure application, which this is a pretty significant savings. The application fees in a lot of these farm systems are more significant than you might expect. One other benefit that we could see with this 360 rain, it was really the initial thing that it was designed for is irrigation. Now, in a lot of dry years, you might see in Iowa that we don't irrigate very often. A lot of our fields are rain fed and we do pretty well with that. But if you already have this machine, now it's an extra tool that you can be using for both digestate application and irrigation in some dry years. And so that could be another source of supplemental income coming from this machine. Now, the main key takeaways that I want you guys to have here. First, digestate storage is a barrier to anaerobic digestion on a lot of our Iowa deep pit swine farms. And that's because now you need to have the storage, you have to have the digester, and it's not something that we see in a lot of dairy systems. So if we can apply our digestate more frequently, we're going to be reducing the amount of digestate that needs to be stored. And so we can cut down on the amount that we're spending on our digestate storage. Additionally, by minimizing the amount of digestate that you're storing, we're minimizing our methane emissions as well. And in doing so, we're having opportunities for LCFS credits and additional income coming to your digester system. Finally, the 360 rain from 360 Yield Center presents some opportunities for us for year-round autonomous digestate application. And I think beyond that autonomous application and being able to get rid of it, you have the additional benefits of this system of improved nitrogen application timing, reduced labor costs, and your crop irrigation. And like I mentioned before, your reduced methane emissions. So, in conclusion, spring, side dress, and split applications of digestate will improve your farm's income and reduce the environmental impact that you have. With that, I'd like to thank you. I'd be open to any questions.
Okay, so that is the presentation we had from Jake. I do see we might have a couple of questions already, but I have a couple last PowerPoint slides for housekeeping that I'd like to share before we get to those. So if you bear with me for just a second. So as a reminder, our next webinar will be May 13th, and we have Andrew Wadle coming to talk to us about roller compressed concrete at beef and dairy lots. So historically, those have been hard places to put projects because the manure gets mixed with some dirt. And Andrew's going to talk to us about the use of roller compacted concrete to hopefully make that manure a little bit cleaner and a little bit more digestible as a result. So I'm looking forward to that. Uh, this work is funded by the USDA, and as part of that, they do ask that if you're so willing to fill out a voluntary demographic survey. So I'll give you a moment to scan the QR code if you are so inclined, but if you're willing to fill that out, we do appreciate it. If you filled it out on the previous webinar, you do not need to fill it out again. And then just a project acknowledgement. This is part of Horizon 2, a climate smart grant that is supported by USDA in partnership with Raceline Alternative Energy, and it's a collaboration to enhance rural vitality, looking at some of the options that farms have to generate more incomes from their manure or hopefully other cropping byproducts. So just for full disclosure, that is the award number for the project, and we greatly appreciate them helping support this work and this webinar series. One of the things we do get asked at the end of these webinar series is, do you make this available online in case someone else is interested in seeing them? We do maintain a YouTube channel. It takes us a couple days to get the YouTube videos posted, but sometime next week, if you're so inclined, you should be able to find the new video on our YouTube channel. And we do try and make the slide sets available through a online box system, so you can go look those later. And I believe we'll have notes and transcripts to the webinar, should you be so inclined. So with that, let's try and take a look at a few of the questions that we've had come in and give Jake a chance to see them. So we have a question from Jim. He was curious about the logistics of the 360 rain, pumping and piping to the field and connecting, disconnecting, and turning at field ends. Could you talk to us a little bit more about how that works, Jake?
Sure, thank you. So I would say it does a pretty good job of addressing that. I guess I'll talk about the turning first. It Well, first of all, it follows the rows, just it follows the planter there. But at when it turns, it's able to lay down its hose in a certain way that it's a very controlled method of doing that compared to a dragline system where you'd be dragging it over the corn. And so there isn't really much damage between this machine and the corn. For pumping, there is a skid that's involved in that price that I included there. And so that would include a well that's dug and the pumping from the manure supply. Now, in a lot of the cases, you could pump straight out of a deep pit if you're applying manure. Here, you would just be pumping straight out of the digestate storage. It can cover probably up to about 200 acres with this machine. And that's if you keep it in one location for its entire life. Now, you may also be able to install some other skids in other fields, and then you could probably transport it around to those other fields pretty easily.
Thanks, Jake. And just to clarify that a little bit more, it does, as it goes down the rows, it will have the outside nozzles, outside Y drops running, and then it backs up the same rows to get to the same spot it was in the field, rolling the hose back up with the interior Y drops running in that case. So it will lay out a hose and then it will collect that hose essentially before it moves over a new set of rows. So that is how it moves through the field. And there would be some labor depending on how many acres you wanted to have it cover, moving the machine around from field to field and what have you. It is also useful to note that the machine probably puts on somewhere around 2/10 of an inch of effluent digestate while it's applying. So in some cases, if your nutrient concentrations are high, you may have to add dilution water to keep the machine full to get uniform distribution. and not exceed the nutrient application rate that you're looking for. So those are some of the logistics that you have to be mindful of making this work. It is still a relatively new piece of technology, but it has been used for manure, and there's people making that work. So I think it definitely has some opportunities in that realm. If there's any other questions for Jake, be sure to put them in the notes section and we'll respond to them. Otherwise, thank you everyone for joining us today. It was great to have you. Last chance for questions. All right, thanks so much everyone for joining us, and thanks to Jake for a great presentation on one of the ways to potentially try and make effluent management at some of these digester projects more economically viable. Later this year, we do have a company who will be talking about some systems they've put on for basically effluent treatment and discharge, and they have some of those systems installed on dairy farms throughout the country. So I'm really looking forward to that as another potential option. So thanks for joining everyone. It was great to have you today, and hopefully we'll see you again next month.